Hi, I'm Paul. We're doing Leetcode must-know interview questions. Today's challenge is longest consecutive sequence. Rating is medium. Given an unsorted array of integers, nums, return the length of the longest consecutive elements sequence. That's probably not going to make sense until we look at an example. You must write an algorithm that runs in O of n time. Yeah, we'll come back to why they specify that. Usually they don't specify that, it's usually at the end like a follow-up or a challenge, like can you write an O of n algorithm? But okay, here, let's look at example one. There's the nums array, and the output is 4. Why is the output 4? Because the longest consecutive element sequence, meaning, if you go through there and just, order the numbers and find it, it's 4. 1, 2, 3, 4. Example 2, if you went through there, you could order those. I see 0, 1, 2, 3, 4, 5, 6, 7, 8, so that's 9. Constraints, nums length is up to 100,000. All the nums will fit in an integer. So yeah, O of n time. Well, because the obvious way to solve this is just to sort the array and then take a pass through it, and you'll get the longest sequence. But they want you to put a little bit more thought into it than that. So let's see. How can we do this in O of n time? Need something to write with. Yeah, I guess that'll work. Okay. Well, let's do this. Let's say that we take one pass through the array and we put all of the numbers in a set. All right. Now we take another pass through the array, and for each number, we look in the set and see if that number minus 1 is in the set. And if it's not, then the number that we're looking at could be the start of a sequence. If 99, for example, were in the set here, then we don't have to consider 100 as the possible start of a sequence. In this case, 99, we're on 100 here. 99 is not in there, so now we start looking forward. We look for 101. That's not in there. So all we get as a longest sequence so far is 1. That's terrible. 1. Let's go to the next number. We have 4. So now we look for 3. Is 3 in the set? It is. So we don't have to think about 4 because 4 cannot be the beginning of a sequence. Next number is 200. Is 199 in the set? It isn't. So we could have a possible sequence here. So we look for 201. It's not there. This one is so ugly. But anyway, the 200, it's not an improvement, but it's just 1. All right. Now we'll go to the next number. The next number is 1. Subtract 1, we get 0. Is 0 in the set? No. So now we can start looking forward. Is 2 in the set? Yes. Is 3 in the set? Yes. Is 4 in the set? Yes. Is 5 in the set? No. So now we've got a longer sequence. Now we have a sequence of 4. All right. Now we're going to get to we're going to also process 3, and because 2 is in the set, we can ignore 3. We will process 2, and because 1 is in the set, we will ignore 2. And so the answer is 4. 4 is the longest sequence, and it's O of n. All right, so let's see what the code looks like. All right, we need a couple of variables before we get started here. We need a set of integers. Let's just call it S. Equals new hash set. All right, and we need one more variable. This is where we're going to keep track of the longest sequence. You know, usually we call these something like RES, result, or ANS, answer, you know, something like that. But initially we'll set that to 0. All right. Next step, put all the elements in the set. So for let's see, I think we can do no, not like that. For int I in nums s dot add I. Enhanced for loop. I think we can do that. All right. Now we take the second pass through the array. For we have to go all the way through this. Yes. And again, I think we can do it like this. For int I in nums if the set if the set does not contain I minus 1. If it does not contain the set I minus 1, then it is it's the start of a sequence. It may only be the start of a one-element sequence, but it is the start of a sequence. So let's do this. Int j equals I. Yeah, that'll work. And then we'll say while, because we want it to go through here at least once, while the set contains j, and it will contain j the first time. So we'll go through here at least once, and we'll increment it. All right, so that is going to go through and get the length of the sequence starting at I, starting at the number I. All right. Now, once we get that, we want to see if it's the new longest sequence. So we'll say if result is less than j minus I, then result equals equals j minus I. I guess we could do that with a math min also. All right. So we've gone through the second time, and we should be able to return the correct answer here. I don't even like this. What if we did it like this? RES equals math. No, we want max. Math, max. Res or j minus I. We don't have to do the computation twice. Should work. A number of things here where I'm saying should work. Let's see what happens. We'll patch it up if we need to. Compile error. Okay, what do we got? Oh, can't find the symbol. Oh, that's right. We're not doing ANS. We're doing RES. RES. All right, run it. All right, that's accepted. Basic test cases. Get a little more space here. Move the frame and submit. Okay. No, wait, wow. Well, gee, I don't feel very good about that. The set, well, it goes in the scorebook as a win, but apparently there is a much faster algorithm, even though, I mean, this is O of n, right? Yeah. Okay. Well, I'm going to do a little research on that and see what people might be doing in terms of an algorithm that is quite a bit faster than what we did. I thought, well, oh well. 52.7. That's funny. Because there's a lot of, okay, so there's a lot right here, but then there's also a lot over here. I don't know, people trading off space for time here in some way. I don't know. I wonder if this thing would catch you know, anyone doing an n log n algorithm and just sorting it. I still don't know why it would be that much faster. Okay, no, well, that's it. I have to admit I'm disappointed with the timing result, but it is a working O of n solution. And thanks for watching. Feel free to like, subscribe, comment, and see you next time.